My name is Rob Eddy. I'm the Resource Efficiency Horticulturist for RII. Excited to have you with us today in the first of our series of 4 webinars that Southern California Edison will be hosting for us. This in particular is very exciting to me that we are focusing on energy reduction. There's all sorts of great information here, things that you can take away. It isn't just theory. It isn't just introductory material. This is stuff that you could really dig into and learn. It's fascinating work, fascinating theory, but it's also applicable techniques that you're going to be able to take home today on how to reduce energy in your facility. Next slide, please. I'm helped today by Bryce Carlton from REI. He'll be the wizard behind the screen, helping me out to make sure I don't make too many mistakes, advancing the slides, answering some of your questions online. If you have a question, you can write it into the chat, and we'll have a question and answer period, but we'll also answer a couple questions probably at the end of each section when it's fresh on the speaker's mind. First of all, we're going to do this poll. We're going to intersperse these through the presentation. So we'd just like to know what kind of facility you are cultivating in. So we'll keep that poll up while we progress through this section, and we'll go over the results at the end of the section. Next slide, please. Here's our agenda. A lot to cover today. We'll be covering energy savings in building envelopes, integrated environmental controls to save energy, greenhouse curtains for managing energy savings and climate, energy and horticulture lighting, and then a few odds and ends energy saving practices. Before, we'll have Caleb Hayhoe from ICF coming in and talking about incentives for energy savings from ICF, which is material you're going to want to hear as well. Next slide. Okay, we'll get into our introductions. Next slide. So I'm going to have the speaker panelists introduce themselves briefly. I'll go first and we'll proceed from left to right. I want you to know all these people and understand the great backgrounds they're bringing to this presentation. My name is Rob Eddy. I'm the Resource Efficiency Horticulturist. As I said, my background is in plant growth facility management. I was at Purdue University for 20 years, managing their research greenhouses, growth chambers, and growth rooms. Prior to that, I worked for Dow AgroSciences as a research horticulturalist at their headquarters. And then I've been doing consulting for a few years after Purdue for cannabis, vertical farms, the ag chem firms, and the biotech firms prior to coming to RII a year ago. And I'm loving it here because we are really making a difference. So I'll turn it over to Luis.
Oh, thank you, Rob. Thank you for the introduction. My name is Luis Trujillo. I work for Hagen. Hagen is a Dutch green and environmental controls company, been in the market for more than 60 years, based in the Netherlands. I'm responsible for US operations. I've been in the industry for more than 9 years. And I'm here to share a little bit of some knowledge and maybe some tools that could be interesting to our guests.
Great. Thank you, Luis. Rob Hanifin.
Hi, I'm Rob. I'm formerly with Ludwig Svensson, a manufacturer of greenhouse curtains or climate screens. I was with them for about 6 years as a climate consultant, helping growers with the selection of curtains for their greenhouses and helping growers to best utilize their curtains to achieve their climate goals. Prior to that, I worked primarily in research, with stints for actually with Dow AgroSciences and with Pioneer Hybrid before that. These days, I'm in the industry. I'm an independent consultant.
Great. Thank you, Rob. Mikhail?
Thanks, Rob, and appreciate having me on the panel and chatting with everyone here. Mikhail Sagal, I'm president of TSR Grow. We've been in business for 14 years, last 8 in horticulture, and really specializing in advanced LED lighting solutions for commercial cultivation, and look forward to sharing some of the innovations and really advances that can be applied in this space that are very synergistic to the whole conversation and energy, and really bringing fine-tuning the opportunity to grow and cultivate at maximize yields and lowest energy costs.
Great, thank you. Caleb.
Caleb has yet to arrive,
Great.
but
Cool.
he is the program manager of AGEE. And later when he joins, he'll be able to give a more in-depth introduction and discuss the incentive programs that are to be offered.
Thank you, Bryce. Next slide, please. Okay, the learning doesn't stop after this presentation. You can access our virtual classroom, which has recordings of the live workshops, tip clips, downloadable resources. Next slide, please. Give you a little bit more detail. We have 2 more workshops coming up, scheduled and all ready to go. It's September 28th, water circularity in CEA facilities, how to reduce, remediate, and reuse. Very excited about that. Just released our best practices guide on that subject, and it's really getting a lot of good attention. People are very intrigued by it. And then October 12th, the critical role of building envelopes and air movement in CEA facilities. Again, these are not introductory material. They're kind of like 201 material, some advanced stuff, not too crazy. Not too hard to understand, and expert panelists who are going to help us get through the information and pass it on in a way that you can absorb and use. Next slide, please. Here's that best practices guide I just talked about. In addition to that release, we've also released another publication that has long been anticipated and getting very good feedback from. This is the CEA Energy and Water Benchmarking Report. Featuring annual resource consumption and productivity of 12 producers growing a variety of crops in greenhouse and indoor facilities. So this is some of the first data that's come out. This data is often held very tightly by these companies, but we worked with them and built trust and aggregated the data so no one could be identified from their data, but it brings us some great conclusions, some good stories about the success of the industry is in that report. So we encourage you to download these. These are free. The REI catalog. Bryce can put the link to that catalog when he's got a moment, but we're very proud of these. Next slide, please. And we also encourage you to contact us about benchmarking your data. What data should you collect? Energy consumption, water quality, production. And I would point out that when you benchmark with us, it's very easy. You work with Bryce one-on-one. He'll tell you exactly what you need to bring. What's great about what we're doing is it's not just estimates, but it's actual utility bill level data. And along with that, we also track productivity. So it comes up with some great KPIs showing how efficient you are using those resources to come up with a good yield. Next slide. All right, let's look at the results of the poll. There we go. Looks like number 1 is small indoor building. Very good. Followed up by a tie between container farms and warehouses, with standard greenhouses being 15%. And of course, doesn't surprise me, we don't have any sealed greenhouses. That's a new technology, and not a lot of them have been built yet, but we thought we'd ask. All right, next slide. All right, now we're going to move on to our technical discussion. I'm going to spend just a few minutes on energy savings from the building envelope and CO2 enrichment before we turn it over to the rest of our panelists. Here's another poll. Should employees with a certification or a credential in resource efficiency practices, for saving energy, saving water, trained in how to do that specifically, is that worth something? Should they be paid more? So we'll leave this up while I talk, and we'll review the answers afterwards. Next slide. So greenhouse coverings, plastics, glass. I'm not going to talk about all of them, of course. This information is out there, published in many areas. You can, in your greenhouse builder, will help you make these decisions. But I want to point out that the theme is the more insulative the greenhouse covering, the higher the R value, the less light transmission you have. So there is that trade-off. Okay, it's just something you'll have to you tend to have to accept. And I should also point out that in California, with the new rules, the last 4 items don't meet the criteria for being for Bryce, remind me, is it code? What's the code number, Bryce? Is it 24?
Yes, Title 24.
24. It doesn't meet the criteria. So single wall acrylic, single wall glass, single polyethylene film, those may not be allowed anymore. So check with your representatives if you're your technical reps at greenhouse construction places if you're building in California. Next slide, please. So although there are lots of different types that you can use, I would point out there's some I'd call it brand new technology. It's not spanking brand new, but it has been proven in industry and in academic research. This is infrared inhibiting materials, infrared inhibiting plastics, typically a film, like a polyethylene film that would go over a Quonset hut. And so this allows the light to come in, but blocks a lot of the heat. So great for energy saving. This has been documented at saving 29% on energy for cooling. Okay. Of course, keep in mind in wintertime, where you're relying on some of that heat from the sunlight, you're probably going to have to add a little bit more heat. But just want to point this out. This is a great product. Also, they're as I understand, they're coming up with rigid plastics that have this infrared inhibiting property as well. Next slide. So that's all about building envelopes. Join us for our 3rd webinar where we'll be focusing specifically on that. And I see Bryce has put the catalog up for that. You can access all of our best practices guide. Thank you, Bryce, for doing that. Next, I want to talk about carbon dioxide enrichment. It's a big topic. It's fascinating stuff. It's basically boosting photosynthesis by increasing CO2, which is one of the required inputs for photosynthesis. But you probably haven't thought about it as the energy savings component. So what you tend to hear about is, you're enriching the environment with CO2 to increase yield. So the natural CO2 level is up in 400 to 450. But if you double or triple that, you can increase yield. Of course, you also have to increase light and temperature to do that. So increasing light, this is not a great way to save energy. You can get some great yield. But you can actually use CO2 with low light and cool temps to maintain a normal yield while saving energy. Okay, normal yield with less energy than it would normally cost if you weren't using CO2. So what's so cool about that to me is you can respond to the market. If you build your facility with CO2 enrichment, and when the market is high, you're getting a lot of return for your product. You can be optimizing yield, but when the market tightens up, you can start using CO2 to maintain your yields while reducing your operating costs. And as I'm describing this, I should point out this is true for liquid CO2 systems. It's probably not true for CO2 burners, so you'll have to get more information on that from experts. And because the burners give off heat for one, so that's a bit of a problem. Might be adding to your cooling load. And also, if the burners are not maintained well, they can release toxic gases for your plants. Next slide. Okay, let's look at the results of our next poll. And it says it's good response that you all think that might be worth being paid a little bit more to have certification, credential, and resource efficiency. Thank you for answering that. Next slide. Okay. So the next sections are going to be on integrated environmental controls to save energy. I've been looking over these slides. You're going to learn a lot here. This is Luis Trujillo from Hogan Dorn, USA. And before he speaks, let's do another poll, and then I'll turn it over to Luis. So here's it's a knowledge check, not a poll. Okay, now we're getting fancy. We're testing your knowledge. Infrared inhibiting greenhouse covering can reduce cooling requirement in the warm season, increase heating requirement in the cold season, or both. So answer that when you got a second. I'm going to turn off my camera so we can focus on Luis. Take it away.
Thank you, Rob. Yeah, what we're going to try to do here in this short period of time is to share some initially some basic principles, some knowledge. This knowledge and principles are based on basically on the plant empowerment, I could say, but are applicable to any type of cultivar, any type of indoor facility, and with any type of technology. They're not really stuck to a technology or to a solution itself. It's knowing more to be capable of doing different, let's say. So our first, let's say, topic would be discovering the principles. Second, applying those principles. Then the integration challenge. I like that because that opens a lot of conversations, and sometimes integration can be a big issue. And then when we have that clear, then we talk about energy efficiency, using those principles, using integration, and applying a plan to make that happen. And the last but not least is talking about some smart energy controls, and that's going into the world of AI and intelligent algorithms and intelligent tools that gather information, make that information decision model so we can take even better decisions to save energy. So next slide, please. So the first discovering the principles, our basic, let's say, core topic as the principles and the plant empowerment principles is what we would say is understanding what the plants need, finding their balance, what exactly they need to produce what we will want to achieve. And this is basically based on three big balances that we call the energy, the water, and the assimilates balance. Those are the balances that we believe the plants need to have as per the requirements. And they're all interlinked via the stomata. The stomata, everybody knows, is the mouth of the plant, and that's where the plant really feeds itself and gathers the resources it needs to produce what we want the plant to produce. And what the plant tries to achieve is restoring these free balances as quickly and as much as possible. So the plant itself is dynamic. So we're not talking here of having conditions, and this we talked a little bit before we started with Rob, that are strict and tight and non-dynamic to the evolution of the environment and of the plant. Also the stage of the plant, the moment of the plant, that type of crop. There we could say the environmental conditions, the infrastructure, the layout, and the location for sure where our crop and our operation is. So if we want to know if the stomata is in a position that is ready to have the best efficiency possible, then we start talking about vapor pressure difference. We call that VPD. That some people might see that a little bit different, but it's similar. Typically, the VPDs should be in a range of 0.3 to 1.5 kilopascals. That's what we have seen in our experience. That will depend on the radiation level for most crops. That's why we say it's dynamic, because that VPD would have to be adapted to that radiation level, the season, the location, and also combined with the temperature, as you will see in the next slide. So most growers adjust the temperature to plant development afterwards. What we're trying to say, it's a little bit different. It's the concept of getting the plant to the perfect balance between temperature and average radiation of the day. So if the plant gets too strong, then the temperature is increased, and if the plant gets too weak, the temperature is decreased. That's how the normal, let's say, growing cycle or growing operation is. What we believe, and this is a little bit of a change of mindset, is that we're going to increase the production as a step one of assimilates by optimizing the photosynthesis. That's the start, let's say, of our process. Step two is use those assimilates to efficiently grow the plant fruits and flowers. And step three, and that's the ultimate challenge and objective, is keep the balance between vegetative and generative development. That means more light, higher temperature, higher average temperature. That's what we call the RTR, the radiation temperature rate. This is accomplished when the average 24-hour temperature and the amount of PAR, that's how we measure the light. Some are in fixed proportion, and that evolves. As the environment evolves, the plant is evolving, and our conditions should be evolving along with the plant. Next slide. So that's basically the main principles. Now, applying those principles our first step to understand is generating reliable data, because that's going to be our basic information and decision model. So what we will have to do, and there we're talking about tools, is gather data, making valuable information using tools that are reliable, that are easy to use, that are connected to the different sources of energy that can give us this information, taking that information and decision model. There's a couple of examples of real, let's say, growing operations at how that energy could look like. For example, there you can see the gas consumption of a facility that grows tomatoes and the climate energy demand of the same facility. That's real and reliable data. And that data is going to become the information model that is going to give us the possibility to predict, taking into account the actual conditions and the forecast, the near forecast of the conditions. There's a big discussion based, and at the end of our conversation, I will tell a little bit more about this, but it's AI was based a lot on historical models in the past, and unfortunately, we have a history of very, very big changes in environmental conditions. The weather has changed a lot in the last 5-7 years. So if we take that data and we use it as the decision model, our decision model is not going to be as reliable and accurate as we need to. So we need to add the history, the present, and the future, and combine those three sources to have a more reliable decision model. And long-term data, that's what can be tricky since weather has changed. Next slide, please, Brent. Now, applying those principles that we talk about big, let's say 2 big chapters, and this essentially could apply mainly to greenhouses, but also apply to the indoor facilities if we look to the supplemental light as let's say the energy, replacing the energy coming from the sun. Insulation is a little bit different, but can also be applied. The first one is working with the RTR and looking to that light temperature ratio to use the best amount of energy from the natural light, that's the sun, or supplemental light. Growing and applying temperature integration more light dependently, that's the dynamic approach, is making those changes and those set points dynamic as per the conditions grow and the plants grows and the conditions change. Using the higher enthalpy of the greenhouse to maximize ventilation, like exhaust, is combining also the other conditions and the airflow, very important for the plants. Harnessing the heat of the day into the night through gradual transitions. It's making those changes in a gradual process, but making those changes happen gradually so the plants keep in balance, but we still keep stressing the plant to achieve the most, also in the night, and maintaining the energy, saving some energy actually. And the ventilation line can be moved further from the heating line if crop condensation, that's another criteria that also is quite important, and too rapid greenhouse temperature rise is prevented. Those items or those variables are key to maintain that energy of the sun as much as possible and maximize that. Then in insulation, we start by promoting the climate balance, homogeneity, by avoiding leakage spots. Rob can tell us a lot about that. Screen to prevent heat demand. That's classical use of the screens to keep the heat in our facility to use that heat. Screening to increase plant temperature without additional heat input. Lower or replace standard minimum tube with air movement. That's a little bit interesting, because that's keeping airflow rate that is within the balance of the plants, and maintain the evaporation 24 hours, 7 days a week, and only stimulate extra when necessary, giving the plants exactly that evaporation rate that they need. Next slide, Bryce. Thank you. Now, when we're talking about indoor farms, and then we talk to supplemental light, we have a couple of experts around here that will give us much more information, but it's what we see is that using the same RTR formula, but based on the supplemental light and the power of that light available, and the environmental set points in the indoor farm. That's the temperature combined with that power value, taking into account the airflow. That's key in the indoor farm. It's one of the most important aspects as we see it. Using that VPD that is achievable, not making, let's say, not defining standards of VPD that we won't be able to achieve with the conditions and supplemental HVAC systems that maybe are too high the targets to keep that humidity low in a certain way. We can work with higher humidities, but combining that humidity with temperatures to achieve the VPD, that makes it feasible in a technological way and in an infrastructure way. Dimming can play a very, very interesting role there. That we will ask the experts what they think about that, and exploring new spectrums of light for sure in that those indoor farms that give us the possibility of playing with those different frequencies to understand that maybe there's a couple of frequencies that work better than others in that facility and with the plans we have. Next slide, Brett. Thank you. Integration. So integration for us, it becomes a big conversation because we have a lot of tools and technology to make them work together. And all the basic concept of integration, and one of the biggest conversations we have is that integration shouldn't be an objective as itself, but the mean to achieve something. That's the key part of the conversation. Integration is making the best use of all the tools we have to achieve what the plants need. That's the core value. So we have a lot of things in our facility, supplemental light irrigation systems, airflow, specialized sensors, CO2 as Rob mentioned, cooling and heating, building management systems, harvesting automation systems, labor management, labor automation, ERP systems. Those are all the different tools that we see in all the controlled environment agricultural facilities, not only greenhouses, but indoor facilities also. And then we start talking of integrating all these systems via different protocols or means or media. That can be low voltage, Modbus, TCP/IP, or BACnet. Those are the most common and used protocols and standards to make those systems talk between themselves. To understand what the plants need in each one of those systems is based using those principles. We know what we want to achieve. Then we have all those tools on our under our facility, and we have to make them talk. We apply those protocols, and then we make this operate always in the most efficient way possible. Next slide, Bryce. Thank you. So the challenges of integration could be the first one, decide the appropriate dashboard based on KPIs, flexibility, and reliability. So that's a very basic, but very important decision. Is that what I'm going to do is that I'm going to integrate the different systems and solutions, but I'm going to have to take a decision of how I'm going to use that data, where I'm going to show it, and how it's going to be a decision model and a tool, a really decision model tool. So that's when we call it a dashboard. That's what we'll define KPIs. So we did the environmental KPIs, basically that's what we're talking, but those KPIs also could be combined with energy KPIs, energy savings targets, energy efficiency targets, and other KPIs as yield, as quality, that combine in a dashboard that can give us a useful and valuable tool to take decisions. Then next challenge is, if we're going to put to talk all those solutions, we have to get all these vendors to fit within a timing and a plan and make them operate and walk through that process in the smoothest way possible. That's one of the challenges. So this can work. This can really take. As I said, integration is not an objective, but a tool to achieve one. And when we have information, this is a basic concept. It's valuable when it's used correctly with a real and identified purpose. Please don't fall within the concept that we're going to have a lot of sensors, that we're going to have a lot of tools around. If we're not clear, what are we going to do with that type of information and what type of tools are we going to be useful for? The technology has to have a purpose, has to have an objective all the time to make it really integrate within the business model and actually make it a reliable and at the end viable solution for any type of controlled environment agricultural facility. Next slide, Bryce. So here's the plan. The initial plan starts with defining the KPIs. We want to know what we want to achieve. And based on energy, it's actually the actual energy consumption per blocks and controls. And those are supplemental lights, CO2, heating, cooling, airflow, and irrigation. So the basic and the most important ones that we see in the production facility. And we have to establish KPIs. Then we're going to define, second, what are going to be our target? how are we going to get to lower where and how those KPIs per control and block. And depending on those targets, then we're going to implement. Based on our tools, we're going to start fine-tuning our tools that can follow up that strategy. We can select the controls, that the tools behind those controls that can achieve the target and produce reliable information to take decisions, taking account integration considerations as part of this process, the implementation, and at the end, refine and fine-tune. Simple. We know we're achieving, we're not achieving, why are we not achieving, fine-tune it with those answers to that why, and continue the process to achieve that energy efficiency plan. Next slide, and Bryce. Now let's talk, last but not least, smart energy controls. Now we're talking about artificial intelligence, and that's basically coming in with some interesting options in the market, and we're seeing those tools apply within the controls to support decision-making and making full operational automation. So this is to make it, let's say, a presentation, the automatic pilot in the plane, the automatic pilot of the car, combined with a GPS. It has a different set of tools behind that all will rely on information. Information here is basically the driver for any smart control. Artificial intelligence uses machine learning tools and machine learning concepts that they learn from the available information. What we're trying to look for this type of tools is less time to trial and error of setting, but more predictive tools to build a plan that has its own dynamics and adapts to real weather conditions or real environmental conditions if we're talking of indoor facilities. And I'm just going to give you an example of how that could happen, is that if we have this type of tool and we're capable of predicting what's going to happen in the next 7 days as the conditions we have, and we're going to achieve in those conditions, we're going to have this amount of yield at this number of units, this kilos for this type of quality. And if we use X amount of energy, there is an example, 30% of the energy, what's going to be the impact on that prediction? And if we're going to produce 3% less, but we say 30%, then the business model and the financial model start to become easy because we have tools to take decisions. We can say it's a no-brainer. It's a good deal. Our profit is going to increase, and we're going to keep a certain level of production not too far away. So it's applicable and it's feasible, and that's the type of decisions we're able to take. So we have balanced environmental strategies with low energy peaks and a yield production based on resource efficiency. All type of resources, energy being one of the most important ones. That's a little bit it of my presentation. I don't know if there's, Rob, some questions.
Thank you, Luis. That was wonderful. I love your motto about integration needs to have an objective. That is a great point. And I would point out one of the things I loved about integrating all my controls and equipment was the ability to do diagnostics, looking at a graph of the temperature or humidity control. Sometimes you work with this every day and you can recognize a blip as what the problem is. And it's long before the temperature would go into a temperature alarms point. You can begin to see, hey, something's not quite off here, and then something's a little bit off. And then you can sometimes just recognize what it is. Oh, that looks like one of the fans is out. Not both of them, but just one of them, for example. And glad you pointed out that AI will also help us not just make better environments for the plants, but also to be tied in with matching up with low energy peaks. So wonderful stuff. Bryce, let's look at the poll results for the next, where we have a knowledge check or a poll result.
The knowledge check results. Are you able to see this?
I am not. Oh, there it is. Thank you. All right. So 53% got it right. It's both. So well done there. And we're going to start our next section with Rob Hanifin talking about shade cloths and shade energy saving curtains. Before that, of course, we're going to do another poll, and that is a knowledge check tracking the vapor pressure deficit of a cultivation area can help the grower know if the stomata are open. So true or false, we'll keep that open for you, and we'll turn it over to Rob. And take it away, Rob.
Great. Thanks, Rob. I'm Rob Hanifin, and going to this section will be primarily applicable to the greenhouse growers, but I wanted to speak for a little bit about greenhouse curtains and how they can help with energy savings and a few related topics. So I'll start off by going through basically the basics of greenhouse curtains. Move on to managing climate with curtains. I want to discuss a little bit specific energy curtains that I think are useful for California's varied climates. I want to focus a bit also then on diffusion in curtains, and then also the use of multiple energy curtains. And the photo at right is an example of multiple energy curtains. You can see there's one with a little bit of shade on the bottom, and through the gaps there's a transparent curtain above. But we'll get into that more in a second. Next slide, please. So basics of greenhouse curtains, and for starters, greenhouse climate screens, greenhouse curtains. I sometimes use the terms interchangeably, but they are the same item. Their first curtains were first utilized in Europe actually during the energy crisis, initially as nighttime heat blankets for the Dutch glasshouse industry, and they've come a long way since then. Today they're widely utilized in greenhouses worldwide, and I'd go as far as to say that most major greenhouse projects today include at least one curtain, and often and most commonly an energy curtain. In general, curtains are knitted or woven textiles that help with climate management. They are retractable, are able to be bundled tightly, typically utilized on an automated system. Modern greenhouse curtains are typically they're made of one or multiple materials: polyester, polyolefin plastics, aluminum, or other materials, usually held in strips held together with high performance yarns. And I've given some photos, some up close photos of knitted and woven curtains down at the bottom there, at the bottom left. On the bottom right is kind of a little schematic. This kind of explains that how the curtains are able to bundle very tightly. And that's very important because when the curtain isn't in use for energy savings or shading, you don't want the curtain to cause more shading than it needs to. So over time, the curtain structures have been engineered so that they have the smallest bundle possible. And that's achieved through the construction with yarn and alternating strips. Next slide, please. Big differ open versus closed structure is basically differentiating between curtains that are meant for shade and then energy saving curtains, which is going to be the focus for the rest of my slides. At top right, there is at top right, the white curtain. The photo more to the left is a closed structured energy curtain. The photo on the right is an open structured shade curtain. The only difference is that the open structured curtain has an actual gap in the knit or the weave of the fabric, allowing airflow and allowing then as according to the diagram at the diagrams at the bottom right, allows for can allow for airflow to the roof vents while the curtain is fully deployed. Whereas if you have a closed structured curtain or an energy saving curtain, to be able to fully utilize the roof vents, you have to gap. The knitted strips, knitted or woven strips within the curtain determine the shade value, in that they can be translucent or not translucent. Then in general, energy curtains the strips in the yarns can help control condensation and mitigate humidity in the greenhouse, in that those high performance yarns actually usually allow condensation to go through them, helping to mitigate humidity. Energy curtains in general range from transparent to blackout, and every shade level in between. We can go on to the next slide, please. In terms of, in general, in managing greenhouse climate, curtains are used to help manage light, temperature, and humidity. And always, the function of the characteristic of what you're trying to manage is always a function of the curtain's characteristics plus the hours of deployment. So, for example, the shade percentage, equals your instantaneous reduction in PAR in the greenhouse. So if you have, if you're pulling if you use a curtain of 50% shade, that's reducing your PAR by 50% in your greenhouse at that moment. And then, compare that to the hours you use your curtain. That'll then add up to your total, how much your total reduction in your PAR sum or DLI. Similarly with energy savings, energy savings of your greenhouse curtains, of your energy curtains, are achieved by by deploying your curtain, you're trapping the warm greenhouse air underneath and reducing the need for heating fuel to be consumed. Most modern energy saving screens have are usually rated at 40% or higher in reduction in energy, or 40% energy savings or higher. And that's the idea behind that is that when the curtain is in use, it's 40%. It's a 40% reduction in 40% reduction in the energy needed to heat that space at a given time. And then, so the more hours you use your energy curtain, then the more total energy that gets used, and then the higher total percentage of energy saved. As Louise pointed out, the energy curtains can be an important part of applying, maintaining the balances, the three balances that are important for utilized in plant empowerment as well. Next slide. I wanted to point out a few different types of energy curtains that can be applicable, I think, for different greenhouse types, different crop types, and different environments in California. Transparent curtains, such as the one at the top right. So they have the lowest shade value and probably very useful for high light demanding vegetables. Used for year-round for energy savings and for very light shade. For other crops, they may be useful for wintertime daytime use, for helping to save energy while not cutting back on light. At the bottom left are two types of blackout curtains. Blackout is typically used for photoperiod sensitive crops to control the day length. It also can be used for crops, for light abatement, for crops of supplemental lighting, where in situations where you want to prevent light pollution or otherwise keep your light within the greenhouse. Then lastly, energy screens of shading, such as that bottom right, are screens that'll have some level of shade, and useful for any crop that requires frequent shading. And in terms of the shading, I feel that the most useful types of greenhouse curtains that can be utilized also include diffusion, which I'll get into on the next slide. Next slide, please. Oh, great. Diffusion is simply the scattering of light, and a lot of modern energy curtains also have diffusive properties as well. At left, here's an energy curtain that's not deployed. At right, same greenhouse a few minutes later as the energy curtain is deployed. You'll note a great reduction in shadowing, from the greenhouse superstructure. Next slide. So to get into the nitty-gritty with diffusion in energy curtains, I wanted to point out first the difference between diffusion versus haze, and also the concept of Horde scatter. Oftentimes you'll have with greenhouse glazing and in other areas, sometimes the term heat diffusion is used when really what's being spoken about is haze. Haze is the amount of light that's deflected at least 2.5 degrees. Modern energy saving curtains, if they have a degree of diffusion on them, that the diffusion is typically measured in terms of Horde scatter, which is the amount of light that is scattered in all directions underneath the curtain. Curtains are able, in general, curtains are able to provide fairly high Horde scatter up into about 80 to 85%, and that's often a lot higher than diffused or hazed glazing materials. And I've included a link and for more information on this topic, a good the Wageningen University website has a lot of good information on this. In greenhouse energy curtains, the diffusion is achieved by actually diffusive strips within the curtains. And the strips reflect. So at bottom left is what happens to solar radiation going through a say like an aluminum strip, or just a or a strip that's blocking some light. Some of the radiation gets reflected, some is transmitted through, and some is absorbed. In a diffusive strip, in a modern diffusion curtain, much less of the radiation is actually absorbed. There is high reflection, and but also then most of what is not reflected is actually transmitted through in all directions, giving you the diffusive effect. And one of the effects of that on your greenhouse that I always like to point out is that the curtain, because it's not on a diffusive curtain, because it's not absorbing a lot of the radiation, actually remains cooler through the day, and then radiates. And then as the greenhouse, as you move in towards night, there's less heat within the curtain to be radiated out into the greenhouse. So it's another way to keep the crop a little bit cooler over time. Next slide, please. But another big reason that light diffusion can be important to incorporate into your curtains is that it's going to reduce your crop temperature, but also reduce your crop temperature and create more even crop temperature. And this is just an example of that. And at the top left, this is an energy curtain that has about 50% shade on it, and is also light diffusing. It's at top left. It's only partially deployed, and there's a lot of, you can see from the two images to the right of it, there's a lot of unevenness in the crop temperature, and you have some fairly high temperatures across the crop. Bottom left, the curtain has been fully deployed, and the crop temperature is not only the maximum crop temperature is not only less, but it's also the crop temperature is very even. So in terms of diffusion, that's one of the great effects of having deploying a diffuse curtain. You're going to end up with much more uniform temperature and dispersal of light to your crop. Next slide. And I'll finish up by discussing a little bit about multiple energy curtains. And one of the things you can achieve with having two curtains and having at least one of them be a diffusive curtain is you can achieve what we call variable shading. On the right, that greenhouse section has a single screen deployed, a blackout screen, 50%, and this may be one strategy. That's a strategy to reduce heat gain. A heat gain on a warm day is to partially close a single curtain, but you're left with basically zebra stripes on the crop below, areas of total darkness and areas of full sun. So both the light reaching your crop and your crop temperature is going to be very very varied. Whereas at left, you have the same blackout screen is partially deployed, but also there's a second screen, a light diffusing curtain that is also partially deployed. And because of the diffusion on that curtain, you can see, the effects are fairly clear beneath that. You're not you end up with equal light spread and more even lighting across your crop, and as well as more even temperature, as evidenced by the prior slide. Next slide, please. And I forgot to mention that the heat images from 2 slides ago were provided by Ludwig Svensson, as well as this slide. This is a little bit behind the idea of variable shading. So in the top photo top left, the photo at top left, the curtain that is 90% closed is a diffusive curtain, and then there's on top of it is a blackout curtain that's 70% closed. So in this example, during a period of fairly high radiation, the grower wants to limit the light to his crop to 250 micromoles, and he's achieving that by closing the diffuse curtain much of the way, and then closing the second curtain until he achieves the desired light level. At the lower right, now, say this is later in the day, he's getting less radiation, but he still wants to achieve the 250 micromoles of light to his crop. He achieves this by backing off one curtain to reduce reducing the total shade to his crop and allowing more of the natural light in. And that's only achievable by having a diffuse curtain with a second curtain. Next slide, please. Then to wrap up, this is another example of having two curtains and being able to achieve be able to have variable shading. I also will point out here that both of these curtains have diffusion on them, and despite it being a sunny day with both curtains deployed, you're not seeing any shadowing on the greenhouse, on the crop below. In addition, this particular greenhouse is cooled as roof vents that the grower is still actively able to utilize, even with his curtains deployed. And the way he does that is he's able to gaps one curtain below where the other curtain is deployed, allowing for some gaps for airflow in kind of a chimney effect, but without allowing direct light transmission. With that, I will end my talk, and thank you very much.
Thank you, Rob. That was fascinating. That last slide where they have two layers, but he he intersperses the gaps so that the air can get up to the ridge vent. That's very clever. I think I'll also point out that diffused curtains are very effective for increasing yield on tall plants as well. Then one of the slides that Rob had shown was showing a leafy green crop, horizontal canopy, but with diffused light, you're bouncing those photons around the greenhouse, and what ends up happening is the lower foliage tends to get more light photons, so they can actually photosynthesize, rather than the top of the crop getting too much light and the bottom crop not getting enough. It evens it out. So diffusion, diffused curtains will make the greenhouse light more uniform in 2 dimensions, but also more uniform in the 3rd dimension, the plant height. So we will move on to the answer for our next knowledge check. Let's see, tracking vapor pressure deficit of a cultivation area can help a grower. Yep, true. Looks like most of you got that. Well done. We're going to have another poll question, but let me tell you that Mikhail will be up next with talk about energy and horticultural lighting, which I'm looking forward to as well. There's stuff in here that I don't know that's new material for me, so I'm really looking forward to that. Before that, we'll do another poll. Which of these information sources are you least likely to use? Least likely to use. This kind of helps us know where we can be presenting our information better to all of you. So we'll leave that up, and then you can answer it at your leisure. And I'll turn it over to Mikhail for his presentation on horticultural lighting.
Thanks, Rob. Appreciate it, and thank you everyone for participating. It's a pleasure to be here and engaging with everyone. I want to talk a little bit about lighting and energy and how we can really start to look at reducing that significantly over the current state of the art. As we all know, the photon engine of a facility for supplemental or primary is lighting, and in a facility, lighting obviously consumes, there's a lot of data out there, but anywhere from 20 to 40 or even higher percentages of energy in the facility, depending on what you're doing. And obviously there's a lot of technologies that support and augment that, but depending on your situation, it's a significant burden, and energy prices are continuing to go up. So how can we really reduce that? Couple initial approaches obviously are think about lighting early. All too often, lighting is considered as an afterthought. It's thought of as a commodity, and really is not fully vetted in terms of thinking about how it integrates into the full facility. That was fine when early stage lighting technologies were more simple, but as the technology has advanced, it's more important to really bring everything together and not think of things in silos. Another thing, facility design and electric design is critically important for efficiency, and making everything work. Many times, the grounding in a facility is not sufficient, resulting in spikes, surges, damage to equipment, pumps, lighting, significant harmonics going on, and so grounding is a very critical piece that also affects the whole facility infrastructure and efficiency. Another thing is, not all lighting sources are the same. Really need to start to look at what's important, how it works, how it integrates, and really then how that all ties into controls and the rest of the facility design and operation. And controls do make a difference. And as lighting has advanced, it's become the ability to integrate controls has increased significantly. So it's these are all high level things, but that's it's an important thing to really integrate, think of things early, and really plan for what you're going to do. Next slide, please. Just to talk a little bit about the current lighting state of the art. Thinking about initial HID technology, very straightforward, very not many spectrums. So the only thing that one really had to worry about, controls were very limited. And so the things that you're starting to think about are really, focusing on the environment, how to keep things cool, how to manage some of the heat, and really optimize the facility operation. But, with HID, it's you didn't have to think about lighting as much early on and integrate it in the facility design. You could just hang it and operate it. Obviously, there's high maintenance costs, reflectors, lamps, and whatnot, and high energy costs. LED lighting has evolved and really come on and made a huge impact and really brought a lot of advancements to cultivation and horticulture. Lighting recipes abound, depending on the crop that you're growing, whether it's supplemental or indoor as a primary light source, or you're growing different crops of different varieties. There's a lot of different lights that you can use, whether it's far red for certain periods of time, or full spectrum, or any number of other activities. The spectrum is important, and also important to pay attention to it, because there are some spectrums that sometimes are proposed and don't work so well. There's a lot of opportunities for control. And the most important thing is LED lighting brought upon as significant energy savings over HID was 40 to 60%. So next slide, please. The important one of the critical pieces of the current state of the art for lighting is the driver. You have a local driver, sits on every fixture, has very little data or intelligence. You need to, every single one produces heat, is in the facility. If it's in a greenhouse or any facility, it's high in the rafters. And oftentimes, because of the harmonics and all of the switching supplies inside and a lot of the surges, and many times you can have a popcorn effect, and quite a few of them failing at different times, which means a lot of maintenance, risk of contamination, challenges to get up there. If you want to control them, you need to run a dimming wire to every single one, which is problematic. Running dimming wires to every single one causes the challenge of control, really advanced controls or ability to do anything with it. So you have broad zones, very limited, very limited control over which sections. In a greenhouse, less important. Indoor, much more important. For every dimming wire, you need contactors and relay panels to make sure that the control signals are off. And so a lot of additional features, challenges, failure points, and when you're talking acres and acres of facilities for commercial horticulture, local drivers can somewhat be a hindrance to taking LED to the next level. Not to mention some of the heat that they bring into the facility as well, that you have to cool. So the question is, what are some of the alternatives, and how do you really take this to the next level? Next slide, please. And really, the answer is remote power servers. We like to say, ditch the driver. Significant savings in energy. You're looking at taking something and centralizing all of the power within a facility. The remote power servers can be located outside of the grow areas. So maintenance is simplified. You just have to no more going into the grow facility and contaminating anything. All of the serviceability is outside. No contactors or relay panels. Very high efficiencies. You can take all of the high voltage AC in the facility in. You start to have full data and control and feedback of everything everything of all the power systems and all of the lighting. You start to, by decoupling the power and the lighting, you starting to integrate the power into the whole facility system. And you start to save a significant amount of installation in terms of installation savings and costs. You don't have dimming wires, you don't have contactor panels, you don't have any of the downsides of a driver. You start to have data. You can start to support GMP and good agricultural practices with with some of that information. High integration into the building management systems, and you can start to think about real optimizations. Next slide. Here's some, applications of this technology in some of the use cases. Taking greenhouse, for example, whether it's vegetables or tomatoes or vertical vines or large scale floriculture, horticulture, or even hemp farms. Centralization of the power servers in a head house far away from any of the greenhouses allows you to decouple that power from the fixture. You can take all of that energy directly in 3-phase 600, 480 3-phase 600 volt and do that conversion efficiently. All of that maintenance of all that power is now localized and separated from the facility. You can run hundreds of feet out to the facility to power the lights. There's no more climbing up inside. You can now take all of that and every single one of those sections and lights, you have data on what's happening, what's working, what's not working, and you can start to take that data and integrate it into a building management system. Next slide, please. In vertical farming, you have large scale, whether it's leafy greens or microgreens or lettuce or other crops that you're growing. A lot of times you want to control it. You have different strains. You have different varieties that you're growing, and unless you're running a control wire to every single fixture in a facility, you have no way to control that and vary what you're doing. So in this, by centralizing everything, you now have the ability with power and dimming on the same line. You now have the ability to control exactly what you want those lights to do for the crop that's growing beneath them. So now you can start to think about, how do you control and start to direct just the energy you need for what you're growing at that particular time. No more maintenance, climbing racks, going miles to chase down a problem. All of that is now outside of the grow, and all of the controlled environment is focused on the photons. So you're only cooling and conditioning the photons that are being delivered to the plants, not any of the excess heat that's being generated by the drivers. So coupled with all of these things, you can start to really optimize and fine tune what you want to do for what you're growing. Next slide, please. Master recipes. Think about having the ability to direct direct schedules and light levels based on what you're growing underneath a particular plant, and delivering the light level for what it needs at that particular given time. And if you grow something different in a particular room, changing that for the next time. So you start to have infinite zones of control, master recipes for what you're growing, knowledge consistency, repeatability, data. All of these things are going to drive success and bring cultivation to the next level. Next slide. Advantages of remote power technology. Decoupling the power from the light allows you to implement enough power for what you need at any given moment, and have the light fixtures be able to drive and operate at a level based on what you're growing beneath them. Power and dimming on the same line allows you to now have full control and bring all the maintenance outside of the grow room. And you start to look at trying to bring power and integrating that in your facility as part of your facility infrastructure. You're now decoupling things in a way that lighting becomes something that can be replaced, upgraded, and managed, but the power and the control and the integration into BMS, into the building management system, is really advancing to the point where you have a facility that can operate quite efficiently without any contactors or relay panels to turn things on and off. You have significant savings on installation. With centralized power systems, you can start to think about microgrids. You can integrate them into, whether it's cogen or battery storage, demand response, load shedding. You can really optimize the efficiencies. You can also close loop and integrate them into the environment and monitoring solutions. Luis talked a lot about some of the intelligence coming and some of the need for controls and or the capabilities of controls. Well, imagine if you can start to think about crop steering through lighting. We talk about taking the environment and fertigation and nutrient dosing to drive what the plants do. But now we can start to take and really deliver specifically the lights for what's underneath, for the crops that are underneath the lights that are receiving that nutrient dosing based on the environment. So you're not only changing, now you're really taking the environment, driving the light levels based on the crop and what you're growing to optimize exactly what you need and just enough to maximize the yields and minimize the energy. And you can start to realize significant increases in production and reduction in energy loads. One of the things that happens in a large scale facility where you have single level, dimming across the, you get an averaging. Some crops may get too much light that don't need it, and some crops get not enough because you're unable to optimize that light level for what's happening in that facility. Again, with remote power, you can start to, drive GMP compliance and really have proactive maintenance and alerts and notifications. Next slide. Just driving in a little bit on some of the capabilities given, with the right levels of application is, strain control or zone control. Just an example, being able to take the light level and drive the power to where you need it based on what you're growing at any given time and change it. It really is a game changer for commercial. It could be for greenhouses, indoor, vertical. It doesn't matter. You can now fine tune the light levels, based on what you need, when you need it, and how you need it. And it's a key piece to driving energy. And we see you're able to now take energy that you're driving in a facility and probably save 15% energy, if not more, by optimizing exactly what you need, while also increasing yields, because you can start to optimize what you're giving the plants to maximize their growth. Next slide, please. Master recipes. I think it's something that's talked about and envisioned and desired, but now it's possible. Master recipes is what we all need in order to drive a consistent, long-term, sustainable operation, regardless of crop. Whether it's food, medicine, or commodity crops, you want to be able to put in a recipe to drive exactly what you want the lights, the environment to do, and react based on things that are happening to be able to drive long-term repeatable success, measure your KPIs, and really drive consistent, high-quality yields. By being able to configure things, you can put in an advanced recipe. If you're growing, a lettuce or a basil or hemp or some other crop, you can put in that recipe coupled with the right building management system and information that's coming into the whole structure. We can now deliver integrated solutions. As an example, we talked about a lot of the intelligence, the past, the present, and the future. You now have the intelligence to take the lighting piece of it, all of the environment, all the fertigation, and really develop a capable system that can drive, reduce energy, and drive a recipe to deliver exactly what you want repeatedly over time. Next slide, please. And I think this is some of the integration and controls we talked about. But again, this is by bringing in remote power servers, you're going to have extreme efficiency and crop yields over time. Next slide, yield. This is just a recap of the energy savings. Remote power versus local drivers is really making a game changer and taking LED lighting to the next level. You really have huge savings in installation, equipment, reduction in energy, And really, it's a game changer to be able to deliver power to the crop where you need it, when you need it. Next slide, please. So remote power servers, again, tied in with the right building management system, gives intelligence, integrates everything for a complete closed loop solution that really is future proof. And again, I just want to touch on future proof being that you can change your lights, but power now is integrated into the whole facility as a total solution. Thank you.
That was wonderful. Really great. Thank you, Mikhail. I love the ability to have that granularized data for lighting and to be able to link it up the building management system and then have that being controlled by something in touch, an integrated control system for the greenhouse. It's pretty exciting stuff. I can't wait to learn more, but this was a great primer for me. Thank you very much, Mikhail. Hey, we'll do the next poll results, and the looks like the information sources that are least likely to be used are vendor sales brochures or website. Thank you for that. The next one being trade show demo discussion. So great. Thank you for that. Bryce, let's skip down to 69, if you would. We're going to go, I'm not going to talk about energy water nexus because I'm really going to dive deep into that next on September 28th for our second webinar. So we're going to go down and start and have Caleb tell us about incentives, an overview of those provided by ICF. Caleb, are you there?
Yeah, I'm here. Can you hear me?
I'll turn it over to you. I'm so glad you're here.
Awesome. Yeah, I'm sorry I missed the tech check.
Oh, no problem.
Hi, everyone. My name is Caleb. I'm a program manager working for ICF. ICF is the main implementer for the agricultural energy efficiency programs that are being provided to customers in Southern California. Also attending is Ben Cooper, who's a program manager at NSAVE. He is pretty much the second person along with me running this program. There'll be a slide at the end that'll have both of our emails. So feel free to reach out to us with any questions. So I'm going to quickly go over some of the incentives that we offer through our programs. I'm going to start with some of the electrical deemed measures. Deemed measures are the easiest to work with. They allow you to quickly apply with an application and some documentation to be able to receive an incentive for new equipment that has already been installed. Some of the measures we offer include glycol pumps, high bay lighting. Right now, the horticultural lighting does not actually include plant lighting, but ICF is working on a work paper with SCE to be able to offer plant lighting deemed rebates to customers. But right now we are able to have lighting rebates given for areas such as head houses, hallways, storage, or office space. There's also deemed rebates for efficient ag vent fans. Right now they max out at 48 inches in size, but ICF is also working along with another state implementer to change this so that larger size fan can be included. We can also do VSDs on the fans, dust collection fans, and then VFDs on ag and booster pumps. Next slide, please. We also have available to customers custom and NMEC measures. This is a process that requires a lot more time than deemed measures and a lot more direct involvement, but it also allows for a much wider range of equipment to be included and have incentives provided for. So there's lighting measures such as lighting controls. We can work with horticultural lighting, but again, there's a deemed work paper that's being developed right now that will greatly simplify the process. exterior lighting, and again, interior high or low bay LED lighting. We have multiple HVAC measures and refrigeration measures. We can work with post-harvest production facilities as long as those facilities are co-located on the farms. Next slide, please. Further, we have custom irrigation, compressed air, pumping, and then wastewater measures. The incentive levels for these custom measures, including the ones from the previous slide, are paid out based on the kilowatt hour savings and the kilowatt savings. Next slide, please. So next we have some measures that involve gas equipment, including steam traps, storage water heaters, process boilers of various different efficiencies. These measures actually have 3 tiers of incentives. One is for a standard customer, one is for a DAC customer, which is based on a local area classification provided by the state of California. And then lastly, hard to reach customers, which we actually offer direct install on for some of these measures. You'll see some say not eligible and some say no cost. The ones that say no cost, we can actually provide the entire purchase and installation of the equipment for eligible customers. That has a few criteria that you'd have to meet, but if you want to reach out to us, we'll be able to clarify whether or not you're eligible. Next slide, please. Some more deemed measures, gas-related equipment. We have tank installation, fitting installation, and pipe installation. Again, there's 3 tiers of rebates, whether you're a standard DAC or HTR customer. And for some of these measures, HTR customers, we again are able to provide direct installation. Next slide, please. And then lastly, for deemed gas equipment measures, we have greenhouse heat curtains, either replacement of existing or in new construction. And then we also have greenhouse infrared film. Again, 3 tiers of rebates depending on the customer classification. And we do offer direct installation for HTR customers for both heat curtains and infrared film, existing or new construction. Next slide, please. The last thing I have is some custom measures that we offer for gas equipment. These include boiler system upgrades, various different greenhouse controls and heating measures, VFDs, heat recovery, ozone cleaning, and then retro commissioning of greenhouses. Again, there is tiers of incentives for custom measures. There's only 2 tiers for custom measures. There's standard or DAC, and HTR customers would also fall under the DAC rate. Next slide, please. Just going over some of the basic requirements for measures. Again, the equipment needs to be new. The customers must meet the program eligibility requirements. The equipment has to be purchased and installed within the beginning and end date of the program, which for the electric program, it began July 5th of last year, and it's currently slated to end in 2025. The purchase date does need to fall within the calendar year that the application is submitted. There are some exceptions to this, though, so if you fall outside of that range, feel free to still reach out to us. And then lastly, all required efficiencies have to exceed Title 20 and 24 standards. Next slide, please. Just quickly going over some of the delivery and customer services that we offer. Training and education on broader benefits. This includes working with RII, providing building energy assessments and energy benchmarking, again, working with RII. We're able to give ongoing guidance regarding measure installation, such as recommending equipment that can be upgraded. We do offer some assistance in financing. And then again, we have dedicated outreach specifically for DAC and HDR customers. Next slide, please. Here you can see my email and Ben's email. Feel free to reach out to us anytime. Let us know if you have any questions. And thank you. And thanks for having me, Rob.
Oh, yeah. Great to have you here, Caleb. Thank you for that. Some great incentive programs. Bryce, I believe, do we have another poll or knowledge check? I don't think we do for this section. So we'll jump into actionable takeaways. Now, this is kind of hard for me to write because there's so many of them. So I took a stab at it. CO2 can be used to either increase yield or save energy. Advanced controls can help keep balance between vegetative and generative development of a crop. This is accomplished when the average 24-hour temperature and the amount of par sum are in a fixed proportion, that RTR that Louise covered. Energy curtains and shade curtains can be separate textiles, separate curtains, or the same. So you've got incredible flexibility in whether or not it's going to be energy retaining or shade casting or shade blocking, I should say, and or they can do both in the same textile. Light diffusing shade curtains can improve light interception and increase yield. That's been proven in academic studies, and I believe light diffusing glass is used in just about every greenhouse that's built in the Netherlands these days. So it is a proven technology. Fixtures and drivers are no longer required of lighting, saving energy. A lot of great information there, a lot of great advantages to remote power. Water conservation and recirculation can reduce energy costs. We'll talk about that on the 28th. And next, we're going to go to our panel question and answer. Bryce, if you could, let's go ahead and put on slide 82. So we have all of our panelists up here. I don't see any questions in the webinar chat, but I've got some, and we've only got a couple minutes, and I don't mind going a little over because I do want to ask these. Luis, I want to ask you a question first. I know that you serve globally. I know you're all over North America. You have controls installed in commercial facilities in Mexico, US, and Canada. Strictly speaking, for controls and sensors, is it always the same package, or do you have to change the sensors, for example, for a given geography? I just always assume that's the very same package no matter where you are, but maybe you can enlighten me.
Yeah, Rob, thank you for the question. At the end, what we don't really, let's say, the sensors themselves, it can be different, and there's standard, let's say, offer of sensors in the market that we can use almost any of those low voltage sensors. Not only, let's say, just provided by us, but any third party that complies with certain standards and reliability and quality standards, that's good enough for us. And mainly the type of sensors themselves, it will not really depend. It will depend really on the type of crop, I would say, because it will depend what we're going to put a little bit more emphasis in measuring it. Soil temperature, temperature of the environment, humidity of the environment, CO2, leaf temperature. If you want to have a very accurate VPD, that's a very specific sensor. That's an infrared camera that gets the VPD. The power sensors, it could be any commercial power sensor that just gives us 0 to 20 milliamps or 40 to 20 milliamps measurement, and with a good reliability and quality.
That's great. That gives the grower a lot of options then that they can use. As long as they know it's a 4 to 20 milliamp sensor, you can integrate with your systems. That's wonderful. I had another question. Maybe I've lost it in my brain. The infrared cameras or that you talked about to measure canopy temperature, is that used? I know that's used to try to avoid condensation forming on the leaves, but can you also use it? Is it used in irrigation to monitor whether or not it's under drought stress? I've never used that technology.
No, No, not really. Let's say what we really can use it now is VPD, leaf temperature. That's where
More
we
accurate.
focus the use of the camera. Well, for sure, we can relate the VPD as an influence for the irrigation strategy. That yes, but as an influence, but we won't be able to measure, let's say, additional the irrigation, I would say success, if we could say it like that, or the irrigation result in the plant as per the measurement of the infrared. It will still be the VPD that we will be able to measure, and that VPD will take into account all the conditions, but it's still the VPD.
Right. Oh, I'm glad you reminded me that. In addition to making sure the plants aren't getting so cool at night that they're getting below the dew point, the big issue is the audience needs to know you get a much more accurate VPD measurement if you're using the leaf temperature rather than the air temperature for that calculation. Thank you for that.
Correct. That's correct. Yeah.
Rob, a question for you about curtains. How easy are they to retrofit into an existing greenhouse? Is it
Yeah, it depends. It's first off, that's very common.
okay.
But it does depend a little bit on the design of your greenhouse and the superstructure you have up above your crop. If you're talking about going from one type of curtain to another, and you already have an existing system in place, then that's usually not too difficult.
Right.
You may need to change out the wires that the curtain travels upon. Make sure that your motor, if there's like a difference in weight between one curtain and another, you'd want to just double check your motors and that your system wouldn't need any tinkering with. In terms of retrofitting, where you like a greenhouse that has not had a curtain before. Typically a curtain system is installed at the either at the top or the bottom of the truss. So you would normally above any greenhouse lights, any sort of unit heaters you'd have hanging, or any other anything else that would be up there. If you're growing ornamentals, hanging baskets and the supports for those as well. So typically the curtain system can be installed above all of that. Again at truss height. So that would just be something you would have to look into with an installer and or installation company to just determine what sort of system is going to work best for you in your situation and how they can go about it.
Yeah, great. Another quick question, just to make sure I'm still current on my technology. When I was using curtains, two things I know I needed to avoid with using my shade curtains was not to, a lot of growers like to heat up the greenhouse between crops to disinfect it. And so up in the top of your greenhouse, you've got the ridge vents closed and you're trying to heat up your greenhouse. It could be 120, 130 degrees Fahrenheit up there. If you're trying, I know it's the greenhouse is empty, you're disinfecting with heat. That I understood was kind of bad on curtains. And the other thing I remembered was sulfur. Sulfur generators were something that I believe you're supposed to avoid with curtains. There might be a little bit of degradation. Are those things still accurate, or has there been improvements to the textiles?
For the first question, it's going to depend a little bit on the materials, what your curtain is comprised of.
Yeah.
So the best thing there would be to contact the manufacturer of your curtain and just say, hey, I have curtain XYZ. I know it's 50%, 50% polyester and 50%, polyolefin. What's the temperature limit before I'm going to see damage? Because that in general, as like materials have improved over time, the temperature, the upper limited temperature is is going up as well. But that would be something I would check before you go all out. Secondly, in general, try to avoid direct sulfur exposure to the curtains. If you're burning sulfur pots, there's any way to just have them not directed towards the curtain, or even better, when you're burning sulfur, have the curtain bundled,
Yeah.
to minimize any direct contact.
Good advice.
Yeah,
Good advice. You tend to do that at night, so you just need to remember not to be, to bundle them up, so you wouldn't be getting any heat retention that night. But thank you, Rob. Mikhail, got one for you too. The 15% estimated energy savings from the remote power, does that include the energy you'd be saving from not having that extra heat from the drivers in the room?
Yeah, thanks, Rob. Those energy savings, I would say the not including that heat probably would bump that up even further.
Yeah.
It really, that focuses purely on optimization of photons to the plants, and within a grow period and what you're doing, rather than having an averaged amount. So by being able to really focus the photons and the light levels and build a recipe around what the plants need and what you're delivering to those plants over a cycle, you can save 15%. On top of that, by taking the energy out, you do actually see significant savings on some of the environment, HVAC. In some cases, you may add a little bit of dehumidification. You get a little bit more by focusing the photons, you get better growth. And so you, in some cases, may see a little bit higher transpiration, which is all a positive. And so you may see some increase in dehumidification, but you will actually save even more energy over the 15%.
Wonderful. I want to, great discussion. Appreciate it so much. I want to thank Southern California Edison for sponsoring this webinar today. I learned a lot. I want to thank the audience for being here today and sticking with me, because the last for my questions that went beyond the shutdown time. I appreciate that. Thank our expert panelists, Luis Trujillo, Rob Hanifin, Mikhail, Sagal, and Caleb Heho. And for Bryce Carlton, I'm Rob Eddy with Resource Innovation Institute, and thank you for joining this webinar today.